Can you elaborate on the role and necessity of the PFAS delay column in this workflow?
The delay column essentially is just a very small column that's in front of your actual analytical column. Like we mentioned, components of the HPLC system used in the analysis may contain some PFAS. So that could be solvent, lines, or degasser membranes, or they could all be manufactured from these fluoropolymer things. Any PFAS in the system could therefore then be extracted into the mobile phase as it passes through the system. Additionally, solvents and buffers to prepare the mobile phase may also contain PFAS. So any PFAS that ends up in the mobile phase will build up on the HPLC column and it'll be released alongside the PFAS in our sample when we run a gradient analysis. So it does lead to inaccurate results. So it sort of keeps it back, that small column, so that the longer column can just get the actual PFAS from your sample, not all the PFAS coming from the system that could skew the results. When we first started working on methods for the PFAS, the first thing we did was run a blanking gradient with no sample injected, and we were easily able to detect like 5 commonly seen PFAS eluting from the system. So we knew that that would interfere with any sample analysis. So we take some steps to deal with the issue, such as replacing those PFAS containing components with suitable alternatives and using very high grade or PFAS dedicated solvents and buffers. But reliably eliminating that background is almost impossible. And this is where the PFAS delay column kind of comes in. The delay column is like I said, like an additional column that we install immediately before the sample injector so that the PFAS that might be present in the mobile phase and trapped on it instead of actually going into the analytical column, which would then get into your detector. So the sample is injected and the analysis is underway. Any background PFAS are physically separated from the PFAS in the sample. So this enables accurate, reliable detection and quantification. So the Avantor ACE delay column was specifically designed for this task, and it uses a highly retentive reversed phase packing material to maximize that separation of any background PFAS that might be present in the mobile phase. So PFAS originating from the LC system and mobile phase can be very hard to control and also is unpredictable. So using a delay column is really necessary for the accurate analysis of PFAS for LCMS.